So when people talk about chemistry, a lot of times they talk about like mixing two chemicals together and seeing what you get. That's basically a chemical reaction. So when we talked about chemical reactions, we talked about it as chemical changes. Remember, we talked about physical changes, things like phase change. Chemical changes are you're getting totally new substances at the end. So when you look, there's always a chemical reaction. So you've got some things that you're mixing together and they're reacting. So those are called your reactants. They're always going to be on the left side. There's always going to be an arrow in the middle to separate the two. And then on the right side, you're going to have the things that are produced. So they're called the products. So what we're going to focus on are looking at chemical equations today. So here, just wanted to show you one for real. So on that left side, you've got the reactants. I know that I'm switching from one to the other because I've got that arrow there. And then on the right side, I've got my products. So we haven't done a lot with this kind of chemistry, but we can look for simple patterns and be able to figure out what type of chemical reaction we're looking at. So that's what we're going to do today. So the first one is synthesis. Now when you're synthesizing something, you're making it. So that's exactly what's happening here. So let's say I was going to make cookies. I'd have a bunch of ingredients, right? Sugar, flour, butter. But on the end product, I'm just going to end up with one thing. I'm going to end up with cookies. So that's what the synthesis general form looks like. I've got some things being added together, but on the right side, on that product side, I've got one thing. I will have no plus signs on the right side because I'm just going to have one thing being made. The opposite of synthesis, making something, is breaking it down. So decomposition is breaking the compound down. So this is going to be the opposite. I'm going to have one thing on the left side, and then I'm breaking it down into separate things on the right side. Then we get to slightly more complicated ones. So single displacement, I'm going to have one single element on the left side, adding together with a compound, and then I'm going to end up with a new compound and a brand new single element. To help you with this, and I apologize in advance, it is so dreadful, but it gets the point across. I like to call this one the home wrecker. So no, I did not take that meme and turn it into chemistry. Somebody else did it for me, but it helps for proving this point. So we've got a couple, copper and sulfate together, and they're happy, la la la, until zinc walks by. And sulfate likes what he sees in zinc. So even though copper and sulfate were a couple on the left side, look who zinc's with on the right side now. Now zinc and sulfate are together, and copper is all single, either living her best life because that dude left or crying because her guy left. I don't know how she feels about the home wrecker, but now copper is a single element by herself. So you can guess, if single displacement was about somebody being single, then double displacement is going to have everybody doubled up. So this time, everybody's a compound. So you've got two compounds on the left and two different compounds on the right. So again, gonna have to apologize. I call this one the double date gone wrong. So we've got two couples, couple A and B, and oh, they're in love, and couple C and D, and they're in love too. So they decide to go on a double date together. But I don't know what went on during the date, but when they left, look who's coupled up together now. We got A and D together and C and B together. So again, we had two couples at the beginning, two compounds at the beginning, and now we have two compounds at the end, but they've switched with each other. So let's practice. Remember, don't get bogged down in all the chemistry of this. We didn't get to learn as much about this stuff as we would have normally. You're looking for patterns. So in the first one, I've got a compound and a compound, making a new compound and a new compound. Since everybody's doubled up, I know that that's double displacement. In the second one, I've got aluminum by itself and a compound, making a new compound and an element by itself, so that's single displacement. Now for single displacement, you do have to have a single element on the left and a single element on the right. That's key. In this third example, I have single standalone elements being added together, but notice on the right side I have one thing. So I've made cookies, so this is a synthesis reaction. And then the last one, I've got one thing on the left breaking down into the other examples, so that's a decomposition. Now, when we're talking about chemical reactions, it requires energy. These things don't just magically happen. So sometimes when you have a chemical reaction, it can be in the form of heat or light. In fact, that's actually how glow sticks work. If you've ever played with a glow stick, you have to kind of break it first. That's because there's a little thin glass vial inside of the glow stick that has one chemical in it, and the liquid that's flowing around is another liquid. And so what happens is when you break that glass, you let them mix together, and you're actually experiencing a chemical reaction that creates light. Now, if it produces heat, that's called an exothermic reaction. So it feels warm to the touch. If you have an endothermic reaction, it actually is soaking up heat, and so it feels cold to the touch. So some practical uses for this, if you've ever had a cold pack where you have to like break it or squeeze it together to get it to work, it's the same thing as the glow sticks. So you've got two chemicals, and when you break it or squeeze it, you're mixing them together, and it's creating that reaction that either warms up or cools down. In the military, they use MREs, meals ready to eat. They have a little heat packet that actually can heat up their food through a chemical reaction without actually mixing it in with the food. Now, the other thing that we can affect is how quickly or slowly these reactions happen. So if you have a slow reaction, you can add a thing called a catalyst that speeds up the reaction. If you have something that you need to slow down, then you add an inhibitor. And an example of this are preservatives in food that basically slow down that process of decomposition.